Let's do another swirly whirly video. The swirly whirly, yay! So there's so many swirly whirlies in our body, and how does a swirly whirly exist? It's because there's some pressure needs to be equalized, or there's an imbalance which is being equalized. Actually, maybe that's not quite the way. Let's say there's a high pressure region. There's some tension that is being released. That's right. When tension is being released, then that's when the swirly whirlies form. When the tension is being released. So there is a kind of swirly whirly that is kind of like a bow and arrow. It's basically, if you imagine you have a torus of energy, like a tornado. Okay. Now, normally a tornado, it goes from a big region up there, and then it kind of converges to a point at the bottom, or converges to a much smaller surface area. It goes from up to down, but you just need to imagine like a vortex like that, but that it's going around in a vortex, and the end connects back up. And so you have to think in your mind, how would that thing stay spinning, and how would the energy keep going around and around and around? If it's like a long, what do you call that? Like a circle. It's connected like that, but it has a vortex going around it, like, oh, maybe that's okay. Yeah, it has a vortex, and it's connected somehow. So how can that work, and how can it keep spinning? So let's just say it does keep spinning until the energy is, released or dissipated slowly. So this torus is kind of like a perpetually spinning tornado that is connected, and it has some inertia to keep it going. And until that inertia, runs out, then it's just going to keep spinning like that. And it wants to stay in this shape. Like if you stretch it out here and let it go, it'll go like a spring. It will spring back. This is very much like a spring. A spring wants to stay at a certain size, at a certain length. If you try to push it down, then there's tension, and as soon as you release it, it will spring back. Or if you pull it out, it requires some energy to keep it out, and when you release it, it goes bang, like it goes back to a center. This is like that, but it's a circle. It's connected. Okay. Normally we wouldn't really be able to. There would not be many analogs for this it's difficult because we think, oh, there's no analog for that. The only analog would be a black hole, and we can't study black holes. So why should you trust me? Because there's no, and why should you trust this kind of logic? Because this kind of concept, because how can there exist such a concept if there is no analog of a black hole? There's no way to prove that we can have that kind of energy, spinning here. But it's easy actually, because there are analogs of black holes actually on Earth. It's just that a black hole, what's happened is that the spinning force, the centripetal inertia, which is spinning in to a point, and it starts here, and it goes, that's not right, and it goes in on a certain spiral. We call that how do you spell? Fibonacci or Fibonacci, I don't know. We call this the Fibonacci sequence, I think. Or you can say ratio, I think. Perhaps we could call it ratio, because it starts at, for example, out here, if this is a certain distance, whereby if this started at, what are the Fibonacci numbers? I forget, but if this, geez, what are they? Yeah, let me see, what is the Fibonacci? Let's just find out here so that we know. Fibonacci sequence, there it is. Fibonacci sequence, okay, so, yes, Fibonacci sequence. Okay, so it goes 0, 1, 1, 2, 3, 5, 13, 21, 34. So that means if this is 34 out there, then this is obviously 0 in the middle, but there is 1, and then it's another 1, and then it's 2, and then it's 3, and then it's a little bit, so it starts close and then a little bit further, and then we get to 3, 5, and then it's 3 plus 5, which is 8, so now it gets even further. Let's say it there, it's 3 plus 5. So let's say that's 1 centimeter or 1 millimeter, and then 1 plus 1, 2 millimeters between there, and then 3 millimeters between here, and then 5 millimeters between there, and then 8 millimeters between there and there, and then eventually 34 millimeters between here and here. And so it just keeps getting, between, yeah, you get it. So it keeps increasing, not by the square root of, actually are they? Yeah, maybe some of them are square roots, I'm not sure, but it just increases by, so that'll increase 1 and 1 plus 2, and then 2 plus 3 is 5, and then so it increases by the previous by the specified amount plus the previous amount, I think is how you would say it, and that's how it increases, like that. But so it's easy because it's going, and that's what a tornado looks like, or a hurricane, or the Milky Way, and also the way the electrons spiral. They are all, you see, everything is spiraling in on that angle. That I think the angle where just before that line disappears into nothingness, it's basically going up into a higher dimension, you could say, or it's crossing a certain, it's crossing a certain level of physicality. It's going down past, let's call it physicality. I think that's a good word. Physicality. Where are my manners? I'm so rude. I'm so rude today. I'm scribbling all over the place. So rude. Okay. Now, yeah. Physicality. So we've got a certain level of physicality up here, and then, a lesser level of physicality there, and then a lesser level of physicality there, and then it just goes down until there's no mass left. There's no mass, okay? But at the bottom point, just before it opens up into a new, so you can see it's going down, just before it opens to the next, the next dimension, or the next layer, or the next, the opposite to mass, just before it gets to negative, okay? So here is, positive, like, 34, positive, I don't know, 8, and then positive 1, and then still positive 1, and then here is negative 1, negative, you know, negative 2, geez, where's the negative? Okay, I'll put it on that side. Negative 1, let's say negative 8, or I don't know, like maybe it's the other, because it's just theoretical mathematics, okay, theoretical mathematics, we don't really, well, no, actually we do, there is a way, then it's hyperspace physics. Yeah, let's write that down here, hopefully you can see. Yeah, that's pretty good. Maybe. Oh, whoops. I think that's supposed to be a Y. What am I doing? Yeah. Hyperspace physics, okay. So here's physicality, and down there is physics. You can yeah, I guess so. For the sake of not having any better word I can think of right now, let's just call this physics and hyperspace. Physicality, yeah, physics and hyperphysics, okay, or hyperspace or counter space. It's a counterbalance for the manifest. For the manifest, the non-manifest. There's a counterbalancing thing for the expressed and the idea, the template, the visualization, or the maybe not visualization, but yeah, the non-material and the material, or you know the. Yeah, I suppose it's like if we have a number line, you know, okay, we're going to have, you know, or it's just, how is a number line? It's probably better like, where did I put that there? Should be able to find where I put things. So there's 0, and then there's like 1, 2, 3, 4, 5, and then we have negative 1, yeah, negative 2, negative 3, negative 4, and so on. Okay. Now, if we can have, so I'm talking about, I guess, a spring. I'm saying it has a certain spring constant. Okay, and so people are saying, oh, there's no analog. There's no way to demonstrate a black hole on our level because it's only something that happens, you know, at the level of like a huge star, when the center transforms to iron and it gets so heavy, it's so much suction pulling through it gets so massive that this part down here starts to get bigger than that part, and then this part, because the negative pulling force. Basically, when something gets to a certain mass in our dimension, you get to a certain threshold where the gravity pulls the mass, and the mass gets so huge that the gravity gets to a point where the physical mass cannot hold itself in the physical dimension. The gravity gets so strong that it sucks the mass through into another dimension, because that's where gravity comes from. That's where inertia, comes from. That's where we're falling into. When I drop this now, it's falling into a black hole, basically. But the black holes are not so small that they're just working as a grounding, as a ground. But they're not pulling it through to the other dimension, because that only happens when you get to a certain density, a certain mass. Then it pulls it through. But there are ways to engineer. There are certain engineering ways to kind of open a black hole or a wormhole. Yeah, there are certain ways to use electrical engineering to do that. Yeah, but these ones are. I'm just talking about, mostly in relation to my discipline, in relation to Qigong. I need to explain this because this explains how the mechanism works, the spring mechanism works in the body. And I'm going to have to erase something so I can draw it again. Okay, I'll use that. So, yeah, I have to draw what the swirly whirly that's like a bow and arrow. I'm saying that there's a swirly whirly that's like a bow and arrow, right? So a bow and arrow. How do you make it bow? Maybe like that and like that and that, and then like that, and then the string, and then you have an arrow. Okay, yeah. So when you pull the arrow, back to here. When you pull it back there, you need some kind of force. You need some kind of force to hold that locked back. Okay, so yeah, let's draw a human. See if we can draw a human. Yeah, so there usually this thing is balanced in here. Normally that's balanced there, but you can pull it so that what happens is that you pull that there, and then that those there are that point there. Okay. Now you need a certain force. And what happens when you let go of that force? What happens when you pull the bow back, you draw the bow back? The way you draw is that you compress. You compress downwards, and that is done via I guess you can say relaxation. Okay. So the way you compress this thing is via relaxation, but you do need some you need some force. You need some forces. You need to use some what is it? Yeah, the deep muscles, or the structural, this, right up here. The structure holding muscular frame. That is it's hopefully trigger. So that is the force that's holding that is a trigger as well, because you can consciously let go of that trigger. So this trigger is something that you have to hold it there. And when you relax that trigger, you release it, you let it go, and then you allow it to sink down. And as you're releasing it, you're still using it. You're not releasing the force completely. You're still having a certain amount of force to hold the frame, so that the mass, the inertia, can sink through and build up at this point here. And because you're focusing all your weight, you're focusing all your mass, which is flowing through the energy channels, and it's going through those two Yongchuan points. We call them Yongchuan. This point here. Now I have to release into my other leg so that I can be stable, so I can stand stably. Release the gravity through my other Yongchuan point, which is here, and then I release it down. So that's what we are training in the beginning, and that's how we release energy through. And the finer you can develop this thing, you can really develop this mechanism in the body to quite an advanced level. Yeah, like some people can probably jump quite far. Actually, they can jump quite far, or they can punch quite hard. They can release not necessarily very hard, but very quickly. I mean, you have a very snap. You have a very good snap in your punches, and you're able to let it go, so you don't stay tense. If you're able to use this mechanism in your striking, it will you'll have that really it will spring back, and you won't need to stay tense. You'll be able to relax it much more than you normally would after hitting that hard. Because after you really hit hard, then it takes some time to relax yourself. But with this kind of spring mechanism, you're just like bang, 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 and you stay relaxed.